Hey everybody, welcome back. Today we're going to start looking at kinematic actors. A kinematic actor is one that can affect physics but not be affected by physics. We're going to use this to be able to create moving platforms and doors inside of Unreal. So I'm going to start by creating a new actor inside of our gameplay folder. We're going to go to a new blueprint, actor type, and we're just going to call it BP kinematic. We're going to start off by creating a cube to represent whatever asset you'd like to move inside of the space. This cube is going to be a static mesh, and so we can modify this at a later time. We're going to also add a few child actors to this. There's a few different ways to use this, to do this in terms of setting up transforms and things like that, but we're going to use the child actor just for simplicity right now. I'm going to press F2 to rename this. We're going to call this pivot, and then I'm going to duplicate it, call it start, and duplicate that and call it end. This will give us the active pivot point, and then the origination and the target pivot for what we want to move the thing from and to. So I'm going to put the cube as a child of pivot, and then I'm going to run over to the event graph. We want to be able to take the pivot, and we're going to set its transform over time. So when we go to set transform, we need to consider that the transform can be set manually, but that doesn't actually help us because we could just set it to that value. What we want is to be able to modify it over time. Generally, what we're going to use for this is something called a lerp. Lerp is short for linear interpolation, which means moving between two things at a set rate. For this, the rate is alpha, and the A is the first thing, and B is the second thing. So whatever transform I have, it's going to try and move from one transform to another transform at the rate of alpha. So if I start off with the pieces here, I have end and I have start. If I get their transform, I want to again grab the world transform. If I grab their transform here, then I can just pop this in, and this will allow me to control if the start or end are at different places, then where I have this alpha value is going to choose between them. Let's set up a begin play to demonstrate this off the bat. I'm going to go back to my level, and we're going to add one of these actors into the world. And so I'm going to modify the cube. We're just going to make it look more like a door to start off. And right now, if I wanted to modify the pivot, you'll notice it'll rotate in the middle of the door, which is not ideal. So we're going to take the cube and we're going to move it in relationship to that pivot. And now it'll pivot from the location that we'd expect, which is the hinge of the door. With that in place, I want to take the pivot and I want to move it to where I'd like the target destination to be. And I'm just going to say, okay, that modified the rotation. I'm going to copy that value, go down to end, and I'm going to paste that value. So end is now in the correct rotation. If I selected end, it'll show in the right location. I'm going to go back up to pivot, and I'm just going to reset that. So this is the starting position. It's going to look like the start. So when I have this, I should expect that on begin play, this will be at the closed position because A is the start position and A is 0, so it'll be closed. If I change this value to 1, then the door should be open. And of course, if I change it to some value in between, we'll go 0.5. Then the door is halfway between open and closed. If I change it to something subtle, like 0.15, then the door will be somewhat cracked open, but not linearly aligned with the way it was in the editor. So this is helpful to get an idea of what the effect of that is, but it doesn't actually tell us how to control it over time. All right, so let's figure out how to do it without using begin play and how to affect this alpha. We're going to use a utility inside of Unreal called the timeline. So if I go add timeline, I'm going to choose this one at the bottom, not add timeline component, but add timeline. And this is going to give us a new node for us to work with. We're going to call this kinematic timeline. So this kinematic timeline has many in execution pins and 2 out execution pins. We can play it, which is wherever it is on the timeline, it'll continue to play forward. Play from start will play from the beginning of the timeline. Stop will hold the timeline at its location. Reverse will move the timeline backwards. Reverse from end will jump to the end wherever it is and play backwards from there. And set new time will allow us to choose where to play or reverse from. And then it'll update for every tick that this is active and the timeline is playing and not stopped or finished, then this will fire off some set of nodes. We're going to connect that to our set world transform. And then when it's done, it'll fire off this finished node. And then we have this direction pin. It's an enumerator for the timeline direction, which is just forward and backwards. And to get an idea of which direction we're going, we could always just run a switch on this. If you didn't care which direction it was finished, you could run straight from that pin, or you can run it from here and say, when I finish moving forward, do this. When I finish moving backward, do that. This node is different from a lot of the other nodes in the Blueprint environment because it can fire without an event pin. It is effectively its own event. So we do want to generally control when it gets fired, but if you have things like looping animations, you can control those through kinematic timelines, or you can through timelines that don't have an event that controls them. So now we need to hook up the timeline to the lerp, and to do that, we're going to need to add a track. We're going to double click on the timeline to get into the timeline editor window. You'll notice that it's in the same asset, it's just a tab within. We have a few things at the top here. The track tells us what type of timeline that we're going to be working with, and you can have multiple tracks together. We can have a float, which is going to produce a single float variable, a vector track, which is going to provide 3 float variables, an event track, which has no concern over value, only the timing, and at certain times it will fire an event on a new execution line, and then add color, which will allow us to change color dynamically over time. We're going to start off with a float track, and we're going to go ahead and call that alpha by default. There's the length of the timeline. If I zoom out, you can see that at 5 seconds it turns back to dark gray. That's how long of the timeline is going to play. I can set the time here to just be 1 second, and that's what we're going to want to do, just to focus in on the 0 to 1 timeline. You can set it to use the last keyframe if you have a curve, which we're going to create here in a little bit. You can use a curve and then just set the last keyframe as the duration rather than using length. So if this is on, it will override length to use the last keyframe. Autoplay does exactly what you think. It will play the timeline when gameplay begins without any event calling directly to it. Loop means that it will go back to the beginning once it gets to the end. We have the ability to replicate and synchronize over network play, and then the ability to ignore time dilation and choose physics groups based off of project needs and optimization. We're going to go into the timeline track now for alpha, and we're going to add a keyframe by right-clicking and saying add key to curve. Or you can hold down shift and left-click and you get another key as well. If I have multiple keys selected, you can tell they're selected by them being blue, and I can control-click to grab them, or I can click and drag to highlight. If you see that they have multiple values, that attribute is not going to be editable, but the values that are shared can be edited simultaneously. So right now, if I leave it like this, the value will always be 0.38. This is not great for us. That just means we're 38% open for the door. What I want to do is set the first keyframe to 0 time 0 value, and the last keyframe to 100% time 100% value, or at 1 second I have 1 whole value. You don't always need to work within the unit of scale, but it is helpful for what we're trying to accomplish here today. So with that set, I can go back to my event graph, and you can see that alpha has been a pin added to my kinematic timeline, so I can now pull that off, and that is going to read off at different durations. So at whatever time I'm at, it will stop the time and check what the value is and read that out. So at half through, I'm going to read half the value. At all the way through, I'm going to read the full value. I can control the smoothness of this by highlighting the curves, and then I can right-click, and I have a few different smooth curve options. I can break it so I can manage the handles independently. I can set each handle by themselves, but they'll be paired left to right. So if I do this, then controlling the left side offsets the right. If I switch it to break, then I can control the left side independently of the right. And if I want, I can set it back to auto. So auto will give us a nice curve, 4 will give us linearity, and then 5 will make it constant, so it'll be like a digital jump. So we're going to stick with 4 for linearity right now in simplicity. Going back to the event graph, I would expect that this is going to do nothing right now because the timeline is not called. We're going to go and set it to autoplay, and so now when I go into play, it'll open the door over 1 second. So this is helpful for us because we now can control what the door is going to do over time by just modifying the end pivot. So if I take this same actor and I clone it over here, I can change it from a rotating door to a sliding door. And if I really wanted to get funky with it, I can take this asset and we're going to modify the cube value, make it 0.1 tall, and we're going to set the interpolation value over here. And so now it's a moving platform. So that moving platform goes out, and it stays out there. So that's nice if you want the platform to just have a visual effect, but to actually have it respond to the player, we're probably going to want to modify this so that it can react to the player. We can have a few different effects of how we would go about that. So we can look at the cube and we can use the cube as the thing that directs this. If I turn autoplay off, I can get my cube and get a function for this. We'll say on component hit, check for the player, and say if it was a player character, then we can just play. Right? So this is helpful to be able to control this. So if it was the player character, I probably want to go to my cube and then under collision, see, simulation generates hit events. There we go. So this means that it'll stop until I touch it, and then it'll do its thing, but then it's kind of stuck. So for doors to open and close, we might want to have different controls for what we're using. So I might have a trigger box that I want to use for this. We'll call that trigger. And the trigger by default isn't going to be used, so we have to set a behavior for that. We'll say on overlap, and we can do cast for the player. So if we cast on the character and it does overlap, then we can fire this off. And then we can also take that trigger and we'll say on end overlap and do the same thing. And we'll run this to reverse. So when the player stops touching it. So I don't want to run basically both of these at the same time. What I probably want to do is control for this with some sort of variable, use asset, use trigger. So I have the asset here, and I probably want to check for that. We'll do a branch, and we'll promote this to a variable. We'll say use trigger. By default is set to false. So if use trigger is false, then we're going to want to use the hit. So we're just going to change that to run off of false. And if use trigger is true, then we want to run these events. And this is really just creating a fairly robust individual asset, but it'd probably be better to make a abstract actor class and then inherit specific details from this. But here I can take that variable and expose it. And then when we get back to our world, if I take my cube, my trigger here, I can move it to the middle of the door, do 50 or 150 and 50 and 100. And for those values, I can just copy that here, and we'll apply that to this trigger as well. And so now if I have these selected and I say for this actor, should be compiled to be able to get that Boolean to be visible. So use trigger is going to be true here. So then I don't need to touch the door physically. I should just be able to get near the door. But this one is still going to be using that trigger. Let's see, that's the default value is use trigger. So we'll turn that off for this one. And it's going to move up. Great. Let's talk about how to move these back and forth. Right now, I could go into my timeline and set up a version of this that has an up and down behavior. So this is nice, but that means I'd have to have a different actor class for each one of these things, even though I'm already kind of creating a set of collections here that tell me some different configurations that I could use for how to interact with the asset. So what I'd like to do is be able to parameterize the way that my curve is going to be working. To do this, I have to start using a curve asset. So I've set up a few curves here inside of my utilities window. I have my unit linear curve, which is basically the one that we created, and then the bounce curve, which is going to go back and forth. So if I come right-click down to miscellaneous and choose curve, I can choose the type of curve that I have. So ease curve, curve float, these are generic curves. These are not, you're not going to be able to do these for things like event curves, but I can choose the float curve, select, we'll do C underscore stationary bounce. So I'm just going to demonstrate creating a keyframe here. So right-click keyframe, add key. And you'll notice that there's no timeline duration. It's just the graph. So with this, if there's something you wanted to move to the left or right, you can do that. But this is not attached to a timeline. The playback is kind of abstract. So if I start this off here, we'll take this up to 1. Let's see, we'll do 1 and 0.4, and we'll take this one to 0.6 and 1, and this will be 0, 0. This one will be 1, 0. And so this will bounce and hang out for a little bit and then come back. So this is how you create a curve. The way you apply it is just through this little drop down. You can list any curve here. So if I use C linear, you'll notice the C linear is exactly what I have here. Hasn't changed any of my behaviors at all. But if I wanted to, I could go to my construction script and I can grab the reference to my timeline and I could say set curve. So if I say set float curve, the name of the one that we're going to reference is alpha, and I can choose from this list, or I can promote this to a variable and say kinematic curve and make that visible to my user here, and the default value we'll just set to linear. That'll be the default if they don't ever pick anything. And now, with that exposed, I could have this asset bounce back and forth by choosing a linear bounce. So this will allow me to get up to the top, hang out for a little bit, and then come back. Now that happened really quickly. I'm going to want to slow that down. Let's go back into our blueprint, and I'm going to want to change my kinematic timeline here, and we're going to say set rate. With a little bit of math, we can see why we're going to appreciate the value of having a 1 second duration, because if I want to set the rate for this, then all I need to do is run a little division where 1 is the numerator and the duration is my denominator. If I want this to run for 4 seconds when it normally runs 1, then 0.25 is the total I want out, which is exactly what 1 over 4 is going to get us. If I want it to run for 2 seconds, then 0.5 is the duration, and so 2 is going to get me 0.5, or 0.5 is the rate. So I can just take this value, promote it here, and call it duration. So with the duration set, I want to get the default value for that to 1. So it'll be whatever the curve is, but then I can control that dynamically by giving it access to the designer. So now I can come back and say this curve should go up for 5 seconds and then down for 5 seconds. So I'm going to put that on a 10-second curve. And now I can write it, and it'll take 5 seconds to get up to where it's going. It'll hang out for a little bit, and then it'll head back down to where I want it to be. So this isn't going to reset. So what I'd like is to be able to control this thing being reset if it gets down to the bottom. So if I wanted to, I could do something like here, switch eTimeline, and if it gets to the end going forward, then I can get the kinematic curve set time, or set new time. Let's see. What is this value? Yeah, it should be set new time. Should be here. Or I can just directly affect it. I can set new time equal to 0. So if it finishes going forward, I can just say set new time equal to 0. So that when I get back to this, whenever it's done, the time will come back to 0, so clicking play will play without having to jump back to the beginning. And I can get it to go back up and down. Alternatively, I could just set this to be something that would, instead of playing forward, I could get it to play forward and then backwards. And then when it reverses, it's already at timeline 0. So there's a number of things you can do with this. I hope the idea of it is clear to you, though, about being able to set child actors, a target transform, and using this lerp behavior through a timeline. These are really the key of anything you want to do. The rest of it is operational to what your specific implementation is going to be. So Take this, play around with it, explore what you can do with different timelines, different tracks. Get out there and keep building.